right? What is that equal to? C square delta T square minus delta L square. Okay? So this is the interval defined in K frame. Instead of ds, I will use delta T. Then if they are infinitely close to each other, then I can use ds simply. Or I can have my ds square is equal to c square dt square minus, let's see, dl square. Where dl will be, what will be dl square? So it is simply dx square or dy square is dx square. Similarly, in k prime frame, I can have k prime frame. I can be having. Okay, now tell me. So I can have this square c square delta t prime square minus delta l prime square, or I can write ds square because it is invariant. That's why I have put ds. Okay. So c square, yes. Delta L prime, or and invariance. What invariance means? Invariance of interval. So what is that? So I am having c square dt square minus dl square. That's equal to c square dt prime square minus dl prime square. Clear? So this is what we have already done. Okay, now let's ask a question. Let's take the first question. Can two events be simultaneous? Okay, let's say if we are having two events happening in one frame of reference, can they occur at same spatial point or at same temporal point in another frame of reference? Okay? You got my point? Okay, so here is one important point. Look, in Newtonian relativity, we are having all events are we can be having simultaneous events. If you are having two simultaneous events in one frame, so they are simultaneous in another frame of reference because t is equal to t prime in Galilean relativity. Is that true? But here we don't have that notion. We can ask a question. Let's say if you are having two events happening in one frame of reference, can they be simultaneous in another frame of reference? Okay? Or can they occur at same temporal coordinate or at same spatial point in another frame of reference? Okay? Clear? Okay. So let's take this first question. Okay? If two events, yes. So I am taking two events, let's say in K frame, they are not simultaneous, they occur at two different points, okay? Now we ask in another frame, can they occur at the same spatial points, okay? Happen at same spatial point. What does that mean? Let's say assume in that is actually K prime frame, where I am saying they are occurring where? At the same spatial point. What does that mean? So this delta L prime, that's equal to 0. So that's actually x2 prime is same as x1 prime, y2 prime is same as y1 prime, and z2 prime is same as z1 prime. Okay? Clear? Is it true?
Yes, sir.
So I am having two events, they occur in K frame at different points. Okay, but I am saying let's assume they occur at, now when I observe these events from the frame K prime frame, that a frame that's moving with respect to K, I assume, let's say, they occur at the same point. Okay, what will happen? What is the nature of these events? Okay, so we can have then this. Okay, now let's see what we can get. So we can have this ds square is equal to c square dt square minus dl square. That's equal to simply c square dt prime square. Clear? Clear? So now tell me. So c is a positive quantity, c square is a positive quantity. So dt prime square, so it is a squared quantity, it's a positive quantity. Clear? Okay, so I can put it as greater than 0. Now what does it mean? What is the physical interpretation of this equation? Okay, what does it yield us? Okay, so let's write it. Okay, so let's rearrange this very term. So I'm having, okay, so this is the condition. Okay, we have arrived at this condition. It implies c square dt square minus dl square is equal to c square dt prime square. Okay, or this way. Okay, let's write it this way, is equal to c square. You can take dt out, dt square. So what you'll get? dl by dt square.
So why not dl square equal to 0? dl square.
Which dl square? So this is in K frame.
So we are also seeing that these occur in same special
No,
K.
you have got my point wrong. Okay, let me put it this way. Suppose you are having two events in one frame of reference. They occur at two different points. Think of the, let's say you send a signal from one point to the another point, okay? One event can be just sending the signal at point A, another would be what? Just receiving it at point B. So it occurs at entirely two different points in frame. Now I am moving, now an observer that's moving with respect to me, let's say, and I say, can he detect them at the same point? Can these two events happen at same point, same special point, not at temporal point, but at the same special point, okay? So in that case, dl prime will be 0, okay? dl is non-zero, okay? Clear? So I can have like this object. What is this dl by dt? So it is c square dt square. So it's 1 minus v square by c square, is it? Am I correct? Now this object is positive, is it? Samajh?
Yes, sir.
This is positive. When this can be, when this can happen? When v is less than c. Clear?
Yes, sir.
So that means we have identified a frame of reference, okay, in where these events can occur at the same special point, and that the particle or the observer has to move at a speed lower than the speed of light, okay? So we are having these events, they are occurring at what speed? Less than speed of light, okay? So these events we call as time-like events. Clear? So we call them as time-like. Anybody having confusion? Yes? Any confusion? So what we have identified, tell me? Yes, completely. So what we have identified, just tell me. We have identified a frame of reference in which an observer or that frame moves at a speed less, or the observer moves at a speed less than velocity of light, and in that frame it can happen, you can observe two events at the same special coordinate, okay, but at different times. Clear? Okay. So now we can have this kind of situation, let's say. So another situation can happen if two events occur at same temporal coordinate. That means, okay, t1 prime is same as t2 prime, or delta t prime is equal to 0, and delta l prime is not equal to 0. The events are now specially separated, but you are observing them at the same time. Clear? So, you got my point? Okay. So what will happen now? So let's write that very relation. So I am having this ds square as c square dt square minus dl squares. Because this dt prime is now 0, so I am having what? Minus dl prime square. So now this object is positive and you are having a negative sign here. So it means this is what? Less than 0. So we are having an events. We are having events while we can observe two events simultaneously. Okay? So for that, for those events, I am having ds square less than 0. Okay? We call those events as space-like events. Okay? So in such case, what will happen? Now if you use the same kind of trick here, okay, you take, so it will be 1 minus v square by c square, is it? It will be all the same thing. Okay? It will, okay, from here you can get like 1 minus v square by c square, and this object has to be negative, is it? When it can happen? When this object is larger than 1, is it? So it means velocity is greater than velocity of light. So that means we have identified a frame of reference where an observer moves at greater speeds than the speed of light. Okay, in such kind of frames, two events can happen simultaneously. Okay, if they are not simultaneously in one frame, but I can see them simultaneously in another frame, but the observer has to move at the speed greater than speed of light. Okay, we call such events as space-like events. Hello? Okay, so there is another possibility. Third possibility is that can an observer move at the speed of light?
Are these, is this possible if we go greater than speed?
No. Speed of light is, we cannot exceed speed of light. So these are the possible events, is it?
Okay, we are only reading it, but practically it's not.
Experimentally it is not possible. Okay, I will show you. Okay, because okay, why these are actually the cases which will help us to identify the distinct regions on the space-time diagram. Okay, so we can have distinct regions which will help us to understand the dynamics of the particle. Okay, which events are observable and which events are not observable. Okay. Okay, and another case is that, is it possible that you can move at the velocity of light? Okay, so let's assume it can happen when an observer moves at the velocity of light. So this is also the possibility. Is this possibility?
Yes.
Now in this case, what will happen? ds square will be equal to 0. Okay, so you can see from here, let's say from this very equation, v will be equal to c and ds will be equal to 0. Okay, so we call these as light-like events. So that means we have identified three frames of references. The one frame of reference, an observer moves with a velocity less than velocity of light. Another observer moves greater than velocity of light, and an observer moves with velocity of light itself. Okay, based on these three things, okay, we can now draw a space-time diagram which will help us to understand these events. Okay, yeah, there is one important point. Okay, let me, because in certain books you will find we are using which convention of G? We are using convention. Okay, tell me, first element is positive, is it? Rest are negative, is it? If I use G as this very convention, while first is negative, rest are positive, then the definitions changes. Okay, in such case, okay, in this very case, ds square less than 0 will be time-like. Okay, greater than 0 will be what? Space-like, and equal to 0 is light-like. But the physical interpretation is the same. Okay, so it will not change any physical interpretation. You got my point? So in that case, okay, if you see, let's say this is less than 0, but this will occur with a minus sign and there will be a plus sign here, is it? So this will be minus and this is plus. So sign change in the terms based on this kind of object. Huh? You got it? Huh? So you can try it yourself and see there will be actually the So since this will be minus sign in that case, and what this will be? Plus. Okay, so you take dt out, so it is minus 1 plus v square by c square. Okay, clear? Okay. Okay, so let's draw the diagram. So we write an event on a space-time diagram is described by a point, okay, and we call that as a world point. So usually we write, okay, so this is the standard convention. So I'll be doing it on a two-dimensional plane. So we draw x coordinate, special component like this thing, and the time coordinate as a vertical axis. Okay, you got my point? Okay, so now we can have a trajectory of a particle. Okay, so let's say we can have it starts from the origin. So this is the trajectory of the particle. We call this trajectory as the world line. Okay, world line is a, okay, you can think along which the particle moves. Okay, the points. So since these are the infinite number of events, okay, so you can draw all the events. We call these points as world points. Okay, so this is actually, this trajectory we called as world line. Okay, got it? Okay, now let's draw our diagram. So this is on, okay, we will take only this thing. So this x naught is our temporal coordinate. Okay, so now let's draw the trajectory of light. Okay, light travels with the velocity, okay, at the velocity c, is it? So now what should be the trajectory of that? Okay, tell me. It is a straight line, is it? That's true. Okay, it is a straight line. So tell me how much straight that will be. Yes. Huh? So are you getting my point? I need to draw the trajectory of light, is it? Okay, at what angle I can draw that trajectory? It is a straight line, is it? At what angle I should draw it? What is the velocity? It is c, is it? So if I divide x by x naught, it will give me velocity, is it? X by t will give me, okay. Let's say x by x naught is what? X by ct, is it? So it's v by c. So tell me what should be. Okay, if I take v is equal to c, this x by x naught is equal to 1. So that the ratio of the axis, if it is 1, so it is 45 degrees, is it? So that means the trajectory of the light should be, okay, so it should subtend an angle of 45 degree with x-axis or both axes. So it is 45 here, so let's extrapolate it this way. Okay, we can have this way as well. So this is, okay, so these are light-like events. Okay, this is the trajectory of the light. Okay, now let's identify from this very region. Okay, so how many regions we have now created? So you are having this very region, is that true? So you are having this region, is it? And then you are having this region and this region. So it's on two-dimensional plane. Okay, we can draw a three-dimensional figure as well, but let's stick to two-dimensional case. Tell me, okay, about this very region. Okay, so this is our which trajectory? Light. So an observer moves at the speed of light, is it? Along these lines. Let's forget these things. Now tell me about this very region. So you are having x naught here and x is here. So what kind of event this would be? What is the speed for a, let's say an observer is moving in this very region. What is the speed of that very observer? No, in this very case. Speed of light is this line. Okay? In this very case. How many less than and how many greater than? Just raise hands. Vertical axis is time. Remember it. It is time. Huh? It is less than velocity of light. Is it? So you are having x by t. Is it? If you calculate the slope, what if that is? Slope will be less than this thing. Huh? Because we are, this is x. If it would have been x, and this x naught, it would have been here. Is it? So much more. Let's forget about. Okay, let's take this as x and this as x naught. Okay, what would be the slope? In this very region, slope is less than 1, is it? Is that true? But we are calculating slope here, it is less than 1 here. Huh? So much we are calculating with respect to this object, x naught. Okay? So that means we are having this very region, which is having velocity less than c. Okay? So this region is known as time-like region. Huh? Okay? So this is also the same thing. This very thing? Is this? So this is exactly the same thing. So this is also time-like. We call this as the past light cone. Sorry. So this okay, since if I rotate it in 3 dimensions, it will become a cone. Okay? It will be like this thing. If I rotate it in 3 dimensions, it will be like this object. Okay? So because we are only in 2 dimensions, if you rotate it, that will be a 3 dimensional. Is it? Will it form a cone like this thing? That's why we call them as a light cones. So this is a past light cone and this is a future light cone. Okay? Light cone. Okay? And this point we call as a present. This point. This origin. So observer is here and it will move an event. Okay? So we'll see in a moment. Okay, so this light. Now tell me about this very region. What is the velocity here? Velocity is greater than. So v is greater than c and v is greater than c. We call these as space-like events or space-like region. Huh? Clear? Okay. Now let's look at this this very region. Okay. So let's start from this very point. So an observer moves and he wants to, okay, you want to send a signal to this very point. Okay, so this is a space, space-like event. How much velocity it requires? Tell me you are having an observer and this observer tries to send a signal to this very point. Okay? So how much velocity he requires? Velocity greater than velocity of light, is it? Is that possible? Okay, so that means I cannot causally connect these 2 events. Okay, let's say if you are having this very event, tell me for this event to send a signal, let's say you are having an observer here and he tries to send a signal to this very point. How much velocity it requires? And that is not possible, is it? So that means all these events are causally disconnected. We cannot connect them causally. Huh? So you cannot send a signal so that another observer will receive that signal, is it? So in other words, all the events in this space-like region, okay, here, they are causally disconnected. Okay? You got my point? Or in other words, we can say they are causally disconnected with the origin. Clear? Okay, now look here. Why we call them as a past light cone and the future light cone? Now, let's say you are having, okay, in past, okay, so this observer is actually moving. So you try to send a signal from here to here, is it? So you can, since velocity is less than velocity of light, you can do that, is it? So that means all these events, let's say you are following a trajectory like this thing or a world line like this thing. So all these events which are happening on this world line, okay, so they are causally connected. Because I can send a signal from one point to the another point, is it? Samashya? You got my point? Okay. Clear? Samashya? So you can move from actually past to future. Actually there is nothing like past and future in physics. Okay? It is just the convention. So you start from here and move here. and also there is no present as well. Everybody understood this thing? Huh? Clear? Okay. Now let's draw. If a body is at rest, what is the world line? How the world line looks like? Suppose you start in a frame of reference. Let's say. So x and x naught. A body is at rest. So it is not. You don't act any force on it. Huh? So what will happen to that? It will remain at rest always. Is it? So tell me, if it is at rest, what will happen to the time coordinate? Only the time coordinate will change, is it? Special coordinate will not change, is it? So let's say you start with a body here, okay? So it will always move parallel to what? X naught. So this will be actually the world line of the body at rest. That's the line parallel to what? X naught axis. Got it? So much here? So this is the world line for a body at rest. In frame, let's say in frame K. Okay? Now if you are having a uniform, body is moving with a uniform velocity, so there is no acceleration, is it? So it will always follow a straight line, is it? So what kind of straight line it will follow? Huh? Okay, let's say it starts from the origin. Just tell me. It will subtend an angle with an axis, is it? So it will, but that line should be within this very light cone, is it? So that should not fall beyond this line. Clear? So if a body is performing any kind of motion, an observable motion, so that should be within these two lines, within the light cone, not outside the light cone. You got my point? Okay. So let me draw this way. So let's draw the two-dimensional axis. I mean two-dimensional plane. So let's call this as x2 and this is an x1. Okay. So then you can appreciate it. So this is x0. Okay. So I am drawing 3 dimensions. So this can be actually, let's say it does not start from the origin, it starts from an arbitrary point. So this will be actually the trajectory of a particle moving in a uniform motion. Okay? So rather an unaccelerated body will follow a straight path. Okay? Yes. Clear? Okay. Everybody is following it? Okay. So light cone will be how? Okay, so it will be like this. You put a point here. Everywhere you put a point, draw a light cone. Check. Okay, so whether this line fits within the light cone or not. Okay, so this. Okay, so this is one ways to look at it. So, but here on the board, I am drawing it this way. Okay. So now let's draw. Okay, let's take a projection of this very line. Okay, onto this plane, x1, x2 plane, that means special plane, okay? So, let's draw the projection. So, it's like this thing. Let's say from the origin, okay, like this way. So, this very line is actually in the x1, x2 plane, okay? So, why from this projection we have got? It's the projection of this very trajectory, is it? Since this trajectory, this line, okay, it is in actually space-time, is it? It contains both space as well as time. But if you look at this very projection, it's only in the spatial domain. Yes, is that true? So we call this as a special trajectory of the particle. Clear? Okay. Now tell me, so you are having an angle, let's say it subtends an angle theta here. Okay, so this is, okay. Now if you look at this very line, this line is parallel to x0, is it?
Yes, sir.
Is that true? Okay, so how much is this very thing? So this very object, so it is actually, it gives me the time coordinate. Let's call that as how much? C delta t. Okay? So now tell me what this will give me, this very line segment. So why, okay, so this line segment is actually parallel to this projection, is it? So it will give me this special length. Is that true? You got my point? So what I am saying, look here, I am drawing a projection onto x1, x2 plane. So this very line, if you see this line and they are parallel, is it? So that means this direction will give me actually the projection where? Or it will give me the special length. So let's call that special length as delta L. Since I am considering only x1 and x2, this delta L will be what? Root of x1 square plus x2 square. Is that true? But if I consider all the three x's, it will be sum of those. It will be like this thing. So this delta L square will be simply as delta x square plus delta y square plus delta z square. Now tell me, so let's calculate this theta. So you are having tan of theta here as delta L by C delta t. What is delta L by delta t? That's velocity. So it's v by c. Okay? Clear? समझ आया? Okay, now let's look at the accelerated body. Okay, since v is less than, so you can see v is less than c, is it? Okay. So now let's look at the accelerated body. For an accelerated body, let's say, so what is the trajectory? It will be simply a curve, is it? So समझ रहे हो? But here is one important point. If you are having an accelerated body, it will be a curved path, okay? Because it's acted by the force, okay? Or it's accelerating simply. What we need